All right. Hey, good evening probably for y'all, morning for me. We're going to learn about graphs and how they shift, reflect, and stretch. But before we do that, we need to be familiar with some of the graphs and some of what we call the parent graphs. No, not that kind of parent graphs. And just look at that. Aren't you glad they're not your parents? I hope they're not anybody's parents that we look at this film. All right, but here's the parent graph. Anybody recognize this one? It's a constant function. And this would be the graph of the y equals 2. All right? The constant one, which is sometimes called a linear. Well, it's still linear because this one's still a linear function. Sometimes also referred to as the identity function because it's identity because y equals exactly x. This is also linear. This would be a linear function. The other was a constant function, linear. So, and you can remember y equals mx plus b. Slope of 1, up 1 over 1. And the y-intercept is 0 because you don't see a plus b there. But that's the parent graph. Ooh, this one's an absolute value function, meaning that you're going to take whatever x is and make it positive no matter what. That's the absolute value graph right there. Remember, these are the parent ones. These are the main ones before they are shifted or acted upon by an unbalanced force. I recognize this one? It's the square root function. Y equals the square root of x. And notice there are no negative x values. So because you cannot square root a negative number. Recognize this one? The quadratic. It's simply the y equals x squared. Notice it's not quite the same distance. Here's 2 here and yet 2 is way up there. So, you know, remember your graphs can be a little deceiving, but it's the parent quadratic function. Y equals x squared. And this one is a cubic function. Basically, it's going to go up a little faster, but yet you can also have negatives because a negative times a negative times a negative is negative, whereas in the squares, a negative times a negative was a positive. Those are the parent functions of the graph, and the ones that we're going to look at first off before they are acted upon, what I call an unbalanced force or shifted.